Hello everyone, my name is Tom Sharon with Rapidform. If you give me just a moment here, I'm going to pull up a slide and we'll get started here in just a moment. Okay, I'm going to go ahead and start now. And I want to first thank everybody for joining us here on this webinar, which is in the morning in the United States, in the afternoon in Europe. And we appreciate everyone joining, taking a few minutes of your time today to learn about fast and easy part inspection using the FARO laser ScanArm and the brand new Rapidform XOV3. In fact, it's so new that it's not actually out on the market just quite yet. So you're getting to see a preview release of the official software that's going to release here in the very short future. So the first thing I want to do is tell you a bit about who we are, the company that makes Rapidform. And our corporate name is Inus Technology. We were founded in 1998 in Seoul, South Korea, and we've got about 100 people worldwide. And Rapidform is in use by more than 10,000 people around the world. 10,000 people in different companies around the world use Rapidform products to process their 3D scan data. We have sales and support in 37 countries via a great network of partner companies like FARO, and we also have a very strong patent portfolio with 35 patents in 4 different countries. And why should you choose Rapidform? Well, we're trusted by thousands of customers. You can see here just a very small list of many of our customers. You can see a lot of automotive companies. In fact, virtually all of the large automotive OEMs use Rapidform in one capacity or another. We're used a lot in aerospace, consumer electronics, education, you can see, and a lot of specialist areas like piano manufacturing and Sandia National Laboratories and Gentle Giant Studios that makes a lot of the special effects that you see in Hollywood. So Rapidform is used in a variety of different industries, and you can see all of these different companies, very well-known brand names, have trusted Rapidform with their inspection and or reverse engineering needs. So now let's talk about our inspection software, Rapidform XOV. And as I mentioned right at the beginning, we're going to be talking about Rapidform XOV3, the brand new version of the software that has some really, really great new functionality in it, especially for working with probe data. And we're going to talk about that, and we're going to show that to you live here in just a few minutes. So a very high-level explanation of what Rapidform XOV is. You start with data from the ScanArm and data from your CAD software, and that can be virtually any CAD software via standard formats, and XOV can also open native formats from most of the major CAD players, including PTC Creo, NX, CATIA, so on and so forth. And then once you open those 2 data sets inside of XOV, you have, of course, your nominal data and your measurement data from the scan or the probe. And inside XOV, you make you go through a full inspection process. You do deviation analysis, color mapping, GD&T, so on and so forth. And then when you're finished with that process, you create a report, and that report can go out via standard Office software like PowerPoint, PDF, Excel, or even in an XML format. You can also share data in 3D via our free viewer, which is Rapidform Explorer, and that's available for download on rapidform.com. If you go there and go to the XOV section, you'll see the free viewer for Rapidform Explorer. So everyone in your organization can download and install that application for free, and then they can open the entire inspection report with all of the information. This is really helpful if you have lots and lots of dimensions, tolerances, or comparison points, and it's too cluttered to show in a PDF type document. You can actually just share the full 3D file, and your colleagues can open it, rotate it around, show and hide things as appropriate. So why should you choose Rapidform XOV over any other scan inspection software? Well, the first reason is that it's the safer, easier inspection software. And what do we mean by that? Well, what we mean is that Rapidform XOV, because it's built on a CAD kernel, just like Rapidform XOR is, it actually has CAD intelligence built into it. So whether you import your CAD model via IGES, STEP, Parasolid, or one of the native formats, XOV recognizes all of the features on that CAD model inherently. It doesn't have to go through any kind of processing or anything like that. It just recognizes the features as a matter of course because the software is built on a CAD kernel from the beginning. And so what that means is that you don't actually spend any time setting up reference geometry that you're then going to measure against from your nominal. You just measure directly off of the nominal. This makes things a lot cleaner, a lot simpler. It reduces the chance for errors, and it saves a lot of time. So that's why we say it's the safer, easier inspection software. Another reason to choose XOV, well, particularly with the release of XOV3, it now has the industry's easiest interface for probing and scanning. So we'll prove that to you here in just a couple of minutes when my colleague Michael will actually do a live demo. But you'll see that the new Live Inspect probing process that's available in XOV is really, really straightforward, very easy to use, and makes the job of actually measuring the part very straightforward, and it's frankly difficult to mix things up, and we know that can happen sometimes when you're probing. And of course, with scanning, XOV is a native point cloud app. That's where it started from, and so it can handle scan data very, very well, collect a lot of data very quickly, and you can see in this screenshot here we actually have real-time deviation color mapping available as you scan. And a third reason why you should choose Rapidform XOV over another option is that it's the only 3D scan software that supports every call-out in the ASME Y14.5 GD&T standard. And particularly in 2D, you'll find that XOV is complete in terms of its ability to do 2D GD&T. It supports all of the callouts as well as 3D. And of course, setting up GD&T inside of XOV by virtue of the fact that it recognizes any CAD model that you import is very, very fast, very, very straightforward. So let's talk about the Rapidform XOV workflow. What do you actually do when you're inside of the application? And the point I want to make here is that it has a very customizable and repeatable workflow by virtue of the fact that it uses a parametric history tree. Again, this is a concept that we've borrowed from the world of CAD to make things very straightforward and very easy to manage. So instead of having to write macros or scripts or record your steps and play them back, we don't have to do that inside of XOV. We have, whether you're inspecting just one part or you're inspecting 100 samples of the same part, it's a very easy setup and repeated process to scan or probe those parts. And it's also very flexible. So you can see here that the general process, and of course this can differ depending on what you're actually measuring, the general process is that you import a CAD file as your nominal data, and you can see that's the very first item in the history tree there. And the second step is to collect the measurement data or import a file of measurement data. And so, of course, that shows up as the second step. And the third step is to align the measured part to the nominal. And in this particular example here of this screenshot of the history tree, we do two different alignments. First, we start with an adaptive alignment that's done with the probe. And then there's a datum alignment that's applied after that. And once we've aligned the part, then of course we can step into measuring it however we'd like to do that. And so that can include deviation analyses, like a whole deviation that you see there, comparison points, that CMP1 is a comparison point, GD&T, you can see a 3D GD&T there, and we also have a cross-section in this example here, and we can do 2D GD&T inside of that cross-section. And then when you're done with that process, you can create a report. And this is all very easily repeatable by simply replacing the second item in the list there, the scan data, and that includes scan and probe data. So you can imagine that if you just delete that second item there and replace it, XOV will automatically run through all of the other steps that you see that come after it. And so we'll end up with a repeated inspection process. And we can easily modify, add to, rearrange the order of, or change any of these steps anywhere along the way. So it's a very flexible system, and that's important, particularly if you're doing first article inspection and you want to iterate through perhaps a few different examples of how to inspect the part. So I'm going to go over some of the feature highlights of the application, and I want to point out here that XOV, of course, being born from the 3D scanning side of the world, does an excellent job with many millions of data points and giving you deviation analysis based on that information. So we have whole deviation color maps, and those give you a quick view of where your part is in and out of tolerance. And you'll immediately see where any problems are. You can define the tolerance for the part or for individual features of the part, which are then shown in green. And everything else that's out of tolerance is shown in shades of red or blue. And you can click anywhere on the model to see exact deviation between the nominal model and the scan at that location. And section deviation is similar to whole deviation. It shows you where a part deviates from the nominal in a sectional view. Silhouette deviation shows the difference between the nominal and the scan part silhouettes or shadows. XOV can even virtually bend light to get a rotational silhouette, which lets you check things like whether an impeller will collide with its housing, which is very cool. Boundary deviation shows where the scan boundary differs from the nominal boundary, and that's ideal for finding trimming problems, particularly in stamped sheet metal parts. Virtual edge deviation automatically extracts the sharp edges of a nominal and the sharp edges of a scan part, even if they're not there in the real world. and it shows you the deviation between the two virtual edges, so you can verify that features come together properly. Once you've completed the inspection in XOV, reporting the results is easy. Reports are created in just a few clicks, and XOV will automatically take screenshots to show the results visually. And you can add data tables with a lot of really deep statistical information about the part that you've measured. You can edit the report inside of XOV, or you can open it in PowerPoint, Excel, PDF, or XML, and it's all, of course, editable there as well. These are not just static tables and images. They are actual tables native in each of those applications and resizable images. We also have trend analysis. So this is a tool that comes with XOV that will take multiple inspection reports and generate a trend report over time. And what that does is it creates charts and tables showing statistical analyses in several process capability indices. So you'll see CP, CPK, that sort of thing inside of the trend analysis tool that comes with XOV. And of course, as I mentioned earlier, there's also Rapidform Explorer, our full-featured free viewer that anyone can download from rapidform.com. And it will open and display entire inspection projects with the history tree. So your colleagues can see all the inspection results. They can even generate their own reports and take additional measurements on the part using the free application. I mentioned this earlier, but I want to reiterate the benefits of parametric inspection history. And you can see another history tree shown here with a lot more elements to it. And this just shows you that, whether it's just a handful of things that you're measuring or hundreds of different dimensions, tolerances, deviations, cross-sections, this sort of thing that you're measuring, all of it is managed inside of XOV's history tree, and all of it's very easily editable at any time, and it's all automatically repeatable as well, because we simply replace the scan data up at the top, and XOV will run through the entire inspection process automatically after that. And as an extension of that capability, XOV also has a batch processing tool. So you can point XOV at a particular folder on your computer, and it will run through all of the data sets that are in that folder and create a report for each one of those. It's even possible to have XOV monitor a folder, and as files are added to it, it will go through and run the inspection right at that moment and generate the report. So that's the quick overview of Rapidform XOV. I'm going to hand things over now to Michael Mock. He is our product manager for the Americas, and Michael's going to give us a live demonstration of the measurement process, both probing and scanning in XOV3.
Okay, give me just a moment. I'm sharing my application. Okay, so hello, my name is Michael Mock, product manager at ComStore. I'm going to be showing you a live demonstration of the software and how it works for probing and scanning of ComStore. So we're going to be taking a look today with our FARO Fusion arms, which is not quite as new as the FARO Edge arm or as compact, but it'll work for today. It's also a little bit less accurate. And we'll be working on the Rapidform demo part. 10
training part that we will ship with every copy of XOV. This is something that we're calling the Rapidform artifact. So we're going to zoom the camera in on the part so you can get a good look at what we're using for probing. And then we have the XOV application here on screen. So on screen, we're going to go ahead and import a nominal file for our physical part. And you can see we have the CAD model shown here. And I'm going to show a little bit about how to set up the inspection, and then we're going to play through an inspection completely. So we can add alignments offline without having any kind of measurement data already. And so we'll start with an adaptive align, which is a probe-based alignment, where we're going to pick points on the nominal model, and then we're going to make these target points that we're going to want to go measure with the probe. And adding that alignment without a device is going to cause this adaptive alignment to be added to our feature tree, like Tom was showing in the PowerPoint. And so right now, there's no information there. It's just a placeholder waiting to play through an inspection process. So in the same method, we can use 3D GD&T to add some additional information to the model. So we'll add a few callouts here. Adding information's quite easy. You just click on the face of the CAD model and place your tag, such as datum A here. And the same thing for dimensions. If I want to measure from this side of the part to this side of the part, I just click and place the dimension. And that's all that's required. Now XOV is ready and waiting for measurement information, and we'll be able to play through this process interactively with the device. So I'm going to go ahead and jump ahead a little bit to a completed inspection process based on the same part and the same ideas that we started there. So here we have the completed inspection process. You can see the same adaptive align idea, and we have two different GD&T features. So you can see we've just added more callouts and information. You saw how that process goes. This is just a few more minutes of going through that process to define all the GD&T and dimensions that we want to measure on our part. Now that we have the process already completed and we're ready to start measuring, we're going to go into the Live Inspect toolbar. So by opening the Live Inspect toolbar, we're given a few tools. The first is that we want to connect to our device. So if we click Connect, it's going to tell us that we're connected to the device. And now we have some tools for ad hoc measurement, whether it's scanning or probing, but we also have a tool to play through an inspection process. And we're going to use that right now, Play Live Inspect Process. So that's going to put us into a measurement mode. And it's going to start directing me to measure different points on the part. So here I see the first point is a flashing point about here on the part. So if I put the probe tip there and take a point, it's going to move me on to the next point. And in the upper left-hand side, you can see it's points 1 of 8. So I'll go over to the next one. For the first 3 points, we won't see update of the probe tip on the CAD model because we don't have an alignment yet. But after the third point, we have a preliminary alignment, and now you can see the probe on the part and on the model. And every point we take after this is going to refine or update the alignment, which is why we call it adaptive align. So I'm going to measure a few more points. And you can see the probe tip's kind of inside the model there, but after I take the point, the alignment is adjusted and the probe tip is moved back outside of the model. So after all of the alignment points have been taken, we're put into what we call a validate mode, where we're going to validate the accuracy of our alignment and the overall shape of the part. So if I come in and touch the model with the probe tip, I get real-time deviation in Z or the minimum distance in 3D space at any point. So I can quickly see, do I have a good alignment? I check the alignment faces that I used, and I can see that there's some deviation here in the middle. So I can see some different trending things, such as I have low deviation here, but I have a bit higher deviation right over here. So there might be some warpage in the part based on that idea. So I can take a tag just by pressing the red button or the green button on the device. Anywhere I see anything interesting, I can take a tag. The same process. So when I have completed the alignment, if I press the red button on the device, I get the option to continue to the next inspection features or retry or reiterate the alignment. So I'd be able to start over and redo the alignment if I had some sort of problem or if the alignment wasn't satisfactory. Now to choose from these options, I could use the mouse, but I can also just use the device. By moving up and down in space, I can choose one of these options and use the green button to select. So now I'm moving forward to the next step, which is GD&T. So you'll see on screen, every face that's purple are faces that need to have some probe geometry added to them. And that's not something that we set up. That's something that XOV is doing automatically based on the GD&T and the dimensions that you've already programmed. So based on those callouts and dimensions, it's determining what faces have to be measured to create the result. And it highlights them in purple for you here. In the upper left, you can see that there are a total of 11 faces that need to be measured, and I'm currently at 0 of 11 that have been measured. So if I come in, I'll go ahead and touch one of the faces, and you see it highlights the face on the CAD model. I don't need to use my mouse at any point. And I'll just start taking measurement points on this face. So now it's blinking, showing me the face that I'm working on. It shows I have 1 point on this face in the upper left. And as I continue probing, you'll see it's flashing and the base color is still purple. After I take the third point, which would be the minimum for a plane, it goes back to flashing to a gray color, the regular color for the CAD face. And every point I take after that just changes the RMS or root mean square fitting value for that face, and you can see that in the upper left as well. So we have an RMS of about 28 micron, so that's actually pretty tight, so that's pretty good. So I'll press the red button, and I don't have to worry about compensation as long as we're using a CAD nominal. The compensation for the probe points is done automatically and parametrically based on the CAD. So I'll go ahead and measure some other faces with the same process. And as I start probing these, we're going to start seeing values start to solve on screen. For example, you can see this flatness up here. It's already solved and it's yellow, which means that it's passing, but it's over 50% of the tolerance value we set. If I measure this face back here, because I measured the one opposite of it, you'll see that the distance between the two here has also been updated and is passing in green. So we'll measure some more features. Again, we'll see the dimension between those two faces there update. And you see that's now yellow, which means it's also in warning. So we'll go ahead and move on to the cylinder. Some of the things you might be noticing, the fact that you don't have to tell the software what we're measuring. It's determining that automatically from the CAD. And when we get to about 5 features left, we start to see this green arrow. And this green arrow is showing us some suggestions about what the next feature we might want to measure would be. So this is very helpful for edges, such as these circles, or also small faces on the model as well. So that lets us find the last few faces to complete our measurement. If we're working on a larger model and we're not looking at the area where the green arrow would be, we get a red arrow pointing us to go back to a certain area to find that information. Now these are still just suggestions. I don't have to follow the green arrow. For example, I can go and measure this face instead. You have the freedom to measure in any order and any process that you want. Green arrows are just a suggestion to help achieve your goal. So if I come in and touch that circle, because I already measured the planar face on top, I just need to measure the points that will be projected to that. So I'll measure some points inside that hole. And you can see the radius value is updated now. It's failing. If I go to the other hole, that radius value also fails, but we see that the center-to-center distance here in the middle is correct and is passing. So this is an example of the size of these circles is incorrect, but the overall distance between the centers is fine. The remaining face is a sphere here in the middle, so I'm going to press the D key on my keyboard, and that's going to put me into a probe scanning mode. And what that's going to do is continuous measurements on the part. So I'm going to come in, touch the face, and just hold down the so I can take multiple points in the streaming fashion, and then just press the D key again to go back to single point measurement mode. So now in the upper left, you can see that I've measured 11 of 11 faces. So if I press the red button, I can go ahead and choose Exit Live Inspect. So here we have our results on screen. So you can see that every value has been solved and is either green for passing or red for failure, or yellow for a warning, which is over 50% of the tolerance value. Since we have this information updated now, we can generate a report with that information. So generating the report is as easy as just updating. And the report's generated automatically based on the feature tree that we have on the left. And after this computes, we'll take a look at the layout of the report and how the information is presented to you. So here we see the report. So we have a cover page here, a page describing what was the nominal data. It shows the file name of the CAD data that we used and some images so that we can quickly tell, was this the correct version of the CAD being used. We have an overall page of all of the scan data or measurement data being used. So here we can see probe points. We'll take some scan data in a moment. That would also be added in here. We get some feedback about the adaptive alignment. And then we get a very drawing-like page describing the 3D GD&T. So here we have a plan view showing all of the dimensions with pass and fail colors on the actual dimensions themselves. And then we get a tabular view showing us all of the relevant information about these values. What was the nominal value? What was the actual value? And what was the deviation and tolerance? So this is the information that we need to know about pass and fail. If we wanted to do repeat inspection, all we need to do is go back to the model, and if we press Live Inspect again, we're given a different kind of prompt. So here it says, do you want to continue Live Inspect, which would be to continue measuring in the same session, adding more information to it, or do we want to reset all the probing data? And so reset all is going to start it over as a new part. So you can put a new part on the table and just run through the process again. So you can do multi-piece inspection easily with this tool. So we'll take a look at scanning in just a second here. So we'll turn off those other pieces of information. So if we go to live capture, this is going to be how we would capture data either with just the probe tip, or we can also use the scanner on the part. So by pressing the red button again, I can choose switch to scanning. I'll bring up the window again. So I can do either real-time deviation or no deviation on the part. So we'll start with real-time first. And you can't really see the laser line on the part in the webcam view, but you can see the line on the screen. We're going to scan the part with the laser line. And we get real-time deviation shown. After every scan pass, we do some automatic processing in real time. So we can collect it. And we won't spend a lot of time here. If I turn off the real-time deviation, I would just standard scan color, which is blue. Pressing the red button again, I get to choose, do I want to switch to probing or do I want to exit? And we want to run the inspection process. And now that we have some scan data, we can do some other scan-centric features that Tom was talking about in his PowerPoint. A good example would be color mapping or whole deviation. We're going to go ahead and create the real color map that we can report directly on them. So here we can see the color map on the part. This shows the overall shape of the part compared to the CAD data. And this information can be updated and added into our report just by going back to the reporting tool. And we can see the whole deviation is that feature there. Will be added to the report if we update. So to review some of the things that you've seen in this webinar, you've seen how easy it is to use XOV to start in your inspection process. At no point did we have to create reference geometry or define what was already inside the CAD model. XOV's CAD intelligence was able to save us the time of having to do those steps. You've also seen how easy it is to interact with and use the device with your either probing or scanning. And you've also seen a small sampling of the GD&T that we have available in XOV. We have all of the ASME Y14.5 standard GD&T callouts, as Tom mentioned in the PowerPoint, including both 3D and also 2D, which is something that's not very common for inspection software. So with that, I'm going to throw it back to Tom, and we can address any questions that you guys might have had.
Thank you, Michael. So yes, I didn't mention this earlier, but we are available to answer any questions anyone has. You can either type those into the Q&A window that you see there in WebEx, or you can even type them into the chat window. Either one of those we'll see, and we'll be happy to answer any of those written questions, and what we'll do is just answer those verbally. And Michael, are you there?
Yes, I am.
We have a first question here.
Okay.
The very first question is, when you do a deviation analysis with the color map, how do you actually, I think the question is, what's the measurement method? Are we doing minimum distance or normal to the CAD model? Can you explain that?
So we've got some options about how the calculations are done. I believe the default is based on the minimum distance. You can also change it to normal based on the CAD surface, ray firing from a specific direction, things like that. So those kinds of options are available to you to get exactly the kind of analysis that you're looking for.
Okay, and another question here is, what are the different types of alignment available in XOV?
So we have a number of alignment types. Supporting the probe, we have the adaptive alignment, which is a probe-specific alignment that we showed today, which is kind of best fitting from target points. We also have datum alignment, RPS alignment, and 3-2-1. Those three, datum, RPS, and 3-2-1, also work with the scanner as well. And we also have automatic alignment based on scan data and best fit alignment based on scan data as well, in addition to transform, matrix, and manual measurement alignments as well.
And someone here is asking about 2D GD&T. We didn't see that on the screen. Can you just talk through what are the GD&T call-outs available in 2D?
Absolutely. In the 2D section mode, we can do 2D GD&T. So that's going to include things such as straightness, circularity, true position is also available, and concentricity, parallelism, perpendicularity, angularity, and symmetry, which are all also available other than straightness and circularity in 3D.
And we have a question here from a person who bought Rapidform several years ago with a different 3D scanner. He's commenting that the software looks much better now. We thank you for that. And can we verbally compare the two Rapidforms? I think what he might be referring to is our older Rapidform 2006 and prior versions. If that's what he's referring to, the answer to that is these softwares are actually completely different. We went back a few years ago and actually rewrote all of our applications from the ground up. And what that allowed us to do was essentially take all of the customer requests that we've heard over many, many years, and instead of sort of tacking them on to an existing product, we just went back and said, you know what, let's build a whole new software application around what we've learned and what we know our customers want, which is part of why you know, we've got the advantages that we've got in terms of being built on a CAD kernel and things like that. Okay, and I don't see any other questions coming in here, and we're close to the expected finish time of the webinar here. So if you've got any questions, type them in real quick. We can answer them. Otherwise, we'll go ahead and wrap up the webinar. And of course, we are available both at Rapidform and at FARO to answer your questions about the hardware and the software. So if you want to follow up directly with either of us, visit us online at FARO.com, Rapidform.com. You can find the contact info for your area of the world there, and feel free to reach out to us. And with that, I'll thank everybody, including the folks at FARO. We appreciate the opportunity here to show how Rapidform works with the FARO devices, as well as Michael Mock. Thank you very much for giving us that live demonstration of the probing and scanning process. Thanks, everyone.